At this episode, we want to know what is an aircraft. We know warmer balloons, airships, civil jets, fighter jets as aircraft, but are they really same or no, they are different? Well, as ICAO Annex number 6, which calls about aircraft operation, we can define aircrafts as two types: airplanes and aeroplanes. Airplanes are lighter than air, and aeroplanes are heavier than air. What we mean? For example, a warmer balloon is airplane. Why? Because it's lighter than air. It's filled by a lighter than air gas, such as hydrogen or helium. And this lighter than air gas causes flying. But aeroplane is made by wood, metal, composites, or something like them, which is heavier than air. And both of them uh, may be power driven or not power driven. Example: warmer balloon is not power driven airplane. Why? Because it's lighter than air. It's filled by hydrogen or helium, which is lighter than air gas, and it has no engine. But airship is a power-driven airplane. Why? Although it's filled by lighter than air gas, usually hydrogen, but it has an engine too that can push it forward. An aerodynamic force which we call that thrust. But aeroplanes are heavier than air because their material is heavier than air. And they are power driven or not power driven. Example: a glider is not power driven airplane because it has no engine and the warm air helps that to fly. But civil jets, fighter jets, uh, or ultralight aircrafts are power-driven airplane. Why? Because their engine helps them to fly. And they are heavier than air because their material is heavier than air. So, at this course, when we call you aircraft structure, we mean power-driven airplane. An aircraft, we mean a power-driven airplane, is including 5 parts: fuselage, which is the basic part; wing, which helps the aircraft to fly; empennage, which causes stability; power plant, which causes thrust force; and landing gear. If we remove power plant, we have non-power driven airplane, and we can remove landing gear too, or change that, such as the airplanes which are landing on the water. So here we have a remember: an aircraft, we mean a power-driven airplane, is including 5 parts: fuselage, wing, empennage, power plant, and landing gear. At this episode, we want to talk about aircraft fuselage. As we told you, an aircraft, we mean a power-driven airplane, is including five components: fuselage, wing, empennage, power plant, and landing gear. At this episode, we want to talk about aircraft fuselage, but there's an important question. Why fuselage? Well, the fuselage is the basic part of an aircraft because it connects all parts on an aircraft together. So, uh, if we remove the fuselage, we won't be able to design an aircraft. So, the most important duty of aircraft fuselage is connecting all parts on aircraft together and forms the aircraft. Uh, but it's important that how it forms the aircraft. So the second duty of aircraft fuselage is generating suitable aerodynamic features, and it depends the art of the designer. That's how he designs uh, the aircraft fuselage to produce the best aerodynamic features. Aircraft fuselage implants cabin, cockpit, and cargo boxes, as this image. In some aircrafts, usually high endurance and heavy and long range aircrafts, uh, the fuselage implants fuel tank too, in addition of aircraft wing, and it absorbs landing time shocks uh, in itself. In landing time, uh, there are some shocks uh, which are entering to the aircraft. The most of them are absorbed in landing gear, but sometimes, such as hard landing time, uh, there's a part of this shock which uh, can't be absorbed in landing gear, and it transferred to the aircraft fuselage, and the aircraft fuselage uh, absorbs that. Well, in aircraft design, we use three types of fuselage: truss, monocoque, and semi-monocoque fuselage. But what are they? Here we start from truss fuselage. Truss fuselage includes longeron, strut, and cables and pipes. Uh, it's used in light and ultralight aircraft. We use two types of truss to design our aircraft fuselage: Warren truss and Pratt truss. But what are them? The Pratt truss fuselage includes longerons and vertical and diagonal members. Uh, Usually, the longeron and vertical members are rigid, and the diagonal members are made by cables or sometimes pipes. Although it has a great weight and it's not so heavy, uh, but it's difficult to streamline. Um, and it's not be able to produce uh, good aerodynamic features. So it's used usually in low-speed aircraft, such as helicopters. And Warren truss fuselage. Warren truss fuselage includes longerons and just diagonal members. There is just two vertical uh, members at the first of Warren truss fuselage. When we want to design uh, our aircraft fuselage, we usually use the both of them, Pratt and Warren truss. We use Pratt truss for the forward and the mid parts of fuselage, and we use Warren truss just at the end of our structure. It has great weight, and as its shape, uh, it has better streamline than uh, Pratt truss fuselage, and it can produce better aerodynamic features, and it has more space, so it can implement some aircraft subsystems, and it's more strong. Here we go to the monocoque fuselage. The monocoque fuselage is used in light and ultralight aircrafts too, and it includes skin, bulkhead, and form. Uh, the main component of this fuselage type is its skin, which is connected to the former and to the bulkhead. The bulkhead can form the inner parts of fuselage too. Uh, it's a little stronger than truss fuselage, but uh, it's not enough uh, for a heavy or medium aircraft. So it's used in light and ultralight aircrafts too. But when we want to design a medium or heavy aircraft, uh, we should use semi-monocoque fuselage. Semi-monocoque fuselage includes longeron, skin, bulkhead, stringer, and skin. The longerons are connecting bulkheads on the length of aircraft fuselage, but we use stringers uh, to make our structure stronger. Example, at this ATR-72 aircraft fuselage, we can see all of these parts. We can see longeron, stringer, bulkhead, and its skin. Here we have a quick look to all types of aircraft fuselage. The truss fuselage uh, has a strong internal structure, but as it don't have a strong skin, so it has a weak exterior structure. What about monocoque fuselage? The monocoque fuselage uh, is not as strong as truss fuselage, but as it has a strong skin, it has a strong exterior structure. And semi-monaco is the mix of uh, truss and monaco. So it has a strong inertial and exterior structure. Aircraft wing. Well, as we told you, an aircraft, we mean a power-driven airplane, is including five components: fuselage, wing, empennage, power plant, and landing gear. Today we want to talk about aircraft wing. Well, what are the duties of aircraft wing? Aircraft wing produces lift force. Lift force uh, is an aerodynamic force which causes flying. And as it produces lift, it transfers aircraft weight. And in some cases, some aircrafts uh, which their engines are under their wing, uh, the wing transfers aircraft engine weight too. Uh, Aircraft wing implants fuel tank, and actually the fuel tank of all of aircrafts are implanted uh, into their wing. Uh, it carries weapons in fighter jets, and it implants landing gear in some aircraft, such as Airbus A300, A310, and these aircrafts. Uh, we told you that the main duty of the wing is producing uh, lift force. But there's a question: how uh, the aircraft wing can produce lift force? Well, here we have a quick look to the four aerodynamic forces which are entering to the aircraft which is flying. There are four aerodynamic forces: thrust, drag, lift, and weight. The thrust force is produced by aircraft engine and moves aircraft forward. The drag is the friction between aircraft and the airflow. Weight depends on aircraft mass and lift. What about lift? The lift force is upward uh, and it starts from center of pressure point. But how this force is produced? Uh, there is an aerodynamic structure called airfoil, and it's the base of lift force. Airfoil is an structure which can produce lift force when it moves in a flight. Uh, One of the bases of fluid mechanics is Bernoulli law. Bernoulli law says that if we imagine two air atoms here, the start of airfoil, both of them should arrive together here at the end of airfoil at the same time. But one of them uh, moves from upper surface and one of them moves on lower surface. As the upper surface is longer than lower surface, so an atom which runs on upper surface should have more velocity. It means that when the velocity increases, the pressure decreases. And here, in lower surface, as this atom runs slower than the other atom, it has more pressure. And this pressure causes a force upward, and it's lift force. And it's wind tunnel. Look at this with airfoil in this wind tunnel. That's how it moves the air. But how we use airfoil in the wing? A wing has some parts. It includes ribs, spar, stringer, and skin. We use airfoil as rib. We can use some different types of airfoil, and if we do that, we call it aerodynamic twist. By the way, here we know uh, about different parts of aircraft wing. Rib. Rib is airfoil formed structure, as we told you, and it produces lift force. But as we want to make our wing rigid, we should fix ribs together. So we can use two structures, a spar and a stringer. What's a spar? A spar is longitudinal mass and connects and fixes the ribs together, and it tolerances aircraft weight. And stringers. Stringers are just booster parts, not the main parts of the wing. They are booster. Uh, in aerospace structures, we have two types of structure: boosted and non-boosted structures. When we use a stringer, uh, it means that our structure is boosted structure, and it tolerances aircraft weight too. And what about a skin? A skin covers the other parts of the wing, and it can produce good aerodynamic features. And it's important because if the skin being damaged, we won't be able to produce lift anyway. Here we have a quick look again uh, about to the uh, components of the wing. We have ribs, which are airfoil forms, spar, which fixes ribs together, the stringer, which boosts our wing, and aircraft wing control surfaces. If you have traveled with an airplane, as the other people call it airplane, uh, you may see something like this from the aircraft window. What are them? Today, we want to talk about them. Actually, there are control surfaces of aircraft wing. For example, in this image, we can see one primary and three secondary control surfaces. Before starting to explain about aircraft wing control surfaces, we should know some things about aircraft axis. An aircraft has three axes: longitudinal, lateral, and vertical. The longitudinal axis is starts from aircraft nose and continues to aircraft tail. The motion around this axis, called roll, encased by aileron control surfaces. The other axis is the lateral axis, which placed between two wingtips. The motion around this axis, called pitch, and it cased by elevator control surface, pitching up or pitching down. And there's another axis called vertical axis between aircraft roof and aircraft floor, and it's perpendicular with the other two axes. And the motion around this axis, called yaw, and it cased by rudder control surface. These three control surfaces, I mean aileron, elevator, and rudder, are primary control surfaces of an aircraft. Elevator and rudder are placed on aircraft tail, and aileron is placed on the wingtip. So here we start from aileron. The aileron is placed in the wing outmount. Also, in some wide-body jet aircrafts, uh, there are another aileron in the aircraft wing inbound and called inbound aileron. It moves upward and downward, and it cases roll. But how? Well, at the last episode of this course, uh, we'll show you uh, rolling and pitching up and down and some other flight maneuvers uh, in flight simulator. But as its theory, uh, the ailerons of the wings are having opposite motion. For example, the right aileron moves upward and the left moves downward, and opposite of that. For example, we want to turn right. What happens? When we want to turn right, the right aileron moves upward and the left aileron moves downward. What happens? Imagine that the aileron is an airfoil. When our airfoil moves upward, it means pitching down. And pitching down means negative angle of attack, and it produces less lift. But the other aileron, we mean the left aileron, it pitches down. It means angle of, it moves excuse me, it moves downward. It means pitching up, increasing angle of attack, and increasing lift. So the left aileron has more lift than the right aileron. So this lift can help the aircraft to turn to the right and opposite of that. What about aircraft wing secondary control surfaces? Flap and slat. Flap is located on the trailing edge, and the air slat is located on the leading edge. Both of them are located in wing inbound, although in some wide-body jets they are uh, outbound flaps and slats too. They just move downward and they increase lift in lower airspeed. How? By increasing airfoil surface, by increasing angle of attack, by increasing uh, camber, and some other things. There are some different types of flap which are used in different types of aircrafts, but the most efficient type is the Fowler flap, and it's more expensive than the other types of flap. And spoiler. As its name, a spoiler is spoiling. But it spoils what? Actually, it spoils the upwash. We mean the upper airflow, uh, which moves on the upper surface of the wing. So it can decrease lift force and help the aircraft to stop. And it just moves upward. Uh, Look at this film in wind tunnel simulator and look at the lift drag ratio. Now we open the spoiler and you can see that what happens for the upwash and how this lift force decreases. Uh, so today we learned about aircraft uh, wing control surfaces, aileron, flap, slat, and aircraft empennage. As we told you, an aircraft, we mean a power-driven airplane, is including five parts: fuselage, wing, empennage, power plant, and landing gear. What's main duty of aircraft empennage? If you play dart, you know that there's an stabilizer at the end of its needle, and it helps needle to fly. And if you remove that, your needle won't be able to fly. The designers designed tail for the aircraft to produce this stability. So the main duty of the empennage is increasing aircraft stability. And they do that with vertical and horizontal stabilizer. These two parts are including some control surfaces too, which case yaw and pitch. And the place between two tails at the empennage is a good place for implanting some aircraft subsystems, such as APU and hydraulic system. The APU is the air power unit, the emergency power unit which produces electricity in emergency evacuations during flight. Well, the designers are designing aircraft empennage as different types, and it depends on the aircraft flight envelope and its mission, such as twin tail, which is usually used in high endurance and super heavy aircrafts such as Antonov 225 Meria. T-tail, which is used for aircrafts which have their engine on the tail. The dorsal fin tail, which is usually used in fighter jets, and standard tail. The standard tail usually designed for the aircrafts which their engines are under wings. Tail or empennage includes some fixed and some uh, control surfaces. Uh, the fixed surfaces are producing stability, and the control surfaces are causing motion. Our fixed surfaces are vertical stabilizer and horizontal stabilizer, and control surfaces are rudder and elevator and trim tabs. But here we have a quick look to our last episode. We told you that an aircraft can rotate around its three axes: longitudinal axis, lateral axis, and vertical axis. We told you about roll the rotation around the longitudinal axis, which caused by arrow, and about the lateral and vertical axis. The rotation around them is depending on tail control surfaces. Rotation around the lateral axis called pitch up and pitch down, and they are caused by elevator control surface, and rotation around vertical axis called yaw, right or left, and it caused by rudder control surface. Okay, here we go. Vertical and horizontal stabilizer, we told you that they produce stability. Vertical stabilizer produces stability around vertical axis, and horizontal stabilizer causes stability around longitudinal and lateral axis. What about control surfaces? First of all, elevator. Elevator causes pitch up or down. Both of elevators are going to the same direction, both of them up and both of them down, and they are moved by yoke or side stick. It depends on the aircraft type. Most of Airbus aircrafts are using side stick, and the other aircrafts usually use yoke. If I push side stick or yoke forward, I have pitch down. The elevators are moving down and I have pitch down. And opposite of that, if I pull that to myself, the elevators are moving upward and we have pitch up. Rudder cases yaw right or yaw left. And it's moved by rudder pedals, which are in the cockpit. If I push the right pedal, the rudder moves right and aircraft moves right. And opposite of that, if I push the left pedal, my aircraft turns to the left. And trim tabs. Trim tabs are secondary tail control surfaces, and they are moved by trim controllers. And they decrease pilot workload. For example, we want to climb with 4 degrees pitch angle. If the pilot pushes and pulls side stick or uke to stay on 4 degrees pitch up, well, it's a great workload. So the designers designed trim tabs to help pilot and decrease his or her workload. Aircraft power plant. We told you that an aircraft, we mean a power-driven airplane, is including 5 components: fuselage, wing, empennage, power plant, and landing gear. A power-driven airplane uses power plant in its flight. So the most important duty of the aircraft's engine or power plant is producing thrust force. This thrust force cases running on the runway or on the earth, and it produces lift force too. Because if we want to produce lift, we should move our structure in there. There are usually 2 types of the engine which are used in aviation and aerospace engineering: piston engines and jet engines. The piston engines are used in light and ultralight aircrafts because they are easy for maintenance, but they have not so much performance. But the jet engines are used in uh, civil jets and some another aircrafts, such as military aircrafts, because although they are expensive, but they have a great performance. We start from piston engines. The piston engine uh, includes 4 states: intake, which fuel and the air are entering to the engine; compression, air and the fuel are compressing; power, which they are fired; and exhaust, which the gases are leaving piston and cylinder. Piston engines are following a cycle called Otto cycle. The Otto cycle is including 2 isentropic and 2 constant volume states. There are 3 types of piston engines: liner, frontside, and radial. In the liner, all of pistons and cylinders uh, are with together as a line. In the front side, they are in front of together, and in the radial, they are as a star. But what about jet engines? There are some different jet engine types which are used in aerospace engineering: turbojet, turbofan, turboprop, turboshaft, pulse jet, ramjet, scramjet, and turboramjet. But as we want to talk about subsonic aircrafts, we just explain about turbojet, turbofan, and turboprop engines. Here we start uh, from turbojet. The turbojet engine is including entrance, compressor, combustion chamber, turbine, and exhaust. And it follows a cycle called Brayton cycle. Brayton cycle is including two isentropic and two constant pressure procedures. The air enters to the engine from here, the entrance. The entrance is usually designed as a diffuser in subsonic engines. Why? Uh, if the air enters to the engine with high speed, the compressor won't be able to compress the air. So the diffuser decreases air speed and increases its pressure. Then this air enters to the compressor and it's being compressed. After that, another diffuser is here, which increases pressure again and decreases its speed. After that, the air enters the combustion chamber and it mixes with the fuel. After firing, the hot gases are entering to the turbine and rotate that, and this turbine is connected to the compressor with a shaft. When the turbine rotates, it rotates shaft and it rotates compressor too. And the hot gases are leaving the engine. Number two, turbofan engine. Turbofan engine is as turbojet, but it's a little different. First of all, after the entrance, the air enters to the fan. A great part of the air is crossing the engine without entering that. This air called cool air. And this air which enters to the engine called warm or hot air. The air, first of all, enters to the low pressure compressor and being compressed. Then it enters to the high pressure compressor and being compressed again. What's the difference between turbojet and turbofan? Number one, cool air and warm air. And number two, more than one compressor. In turbojet, we have just one compressor, but in turbofan, we have two or in some cases three compressors and two or three fans. After high pressure compressor, the air enters to the combustion chamber and being warmed, and it moves to the turbines. It rotates high pressure turbine at the first, and this high pressure turbine transfers power to the high pressure compressor. After that, the air moves to the low pressure turbine, and the low pressure turbine transfers its power to the low pressure compressor. After that, the air leaves the engine. And what about turboprop? Turboprop is a gas turbine engine as turbojet and turbofan. But the most of its power is produced by prop. So, what happens? The air enters from entrance and it's as a diffuser, as you see. The air being compressed by the compressor enters the combustion chamber and to the turbine. The turbine rotates and transfers its power to the compressor and to the prop. But as the most of the power is produced by prop, around 55% of the power. The designers are using gearbox to change RPM between turbine and prop. Aircraft landing gear. We told you that an aircraft, we mean a power-driven airplane is including 5 components: fuselage, wing, empennage, power plant, and landing gear. The landing gear has some duties such as casing aircraft stability on the ground, underlying aircraft taxi and loading on the ground. For example, uh, loading cargo or passengers on the ramp, and it absorbs shocks at the landing time, as this image. At the landing time, a grid shocks are entering to the aircraft, and the landing gear absorbs them, and it underlies aircraft racing at takeoff time, called rolling. Because uh, if we want to start flying, we should reach a special speed, and after that we can climb and leave the ground. If we want to reach this speed, we should run on the runway, called rolling. And the landing gear helps us to run on the runway. Landing gear has 2 types: retractable and fixed gear. The retractable gears are producing a great aerodynamic features, and of course they are more expensive. But fixed gears, which are used in light and ultralight aircrafts, uh, are cheaper, but they are producing drag force, and they are not suitable for high speed aircrafts. And we can have 3 types of landing gear as their station: the nose gear, main gear, and tail wheel in some light and ultralight aircrafts. Landing gear can use in aircraft as many types. Uh, the right image is the different types of main gear, such as single, twin, dual twin, dual twin tandem, a twin tandem called boogie 2. Boogie is a mix of twin tandem and some another uh, parts of aircraft landing gear. And twin tandem, tandem, triple, triple tandem, three twin tandem, and twin three cycle. The landing gear uh, has 6 components. The strut, which connects wheels to the fuselage, axis, which connects 2 wheels together, brakes, ring, which connects tire and the main structure of landing gear, and shock absorber system. The shock absorber system is used as 2 types in the aircraft: spring steel or hydraulic gas oleum. The spring steel is used in light and ultralight aircrafts. It's cheaper, but it's not be able to absorb uh, landing time shocks so much. But the hydraulic gas is more expensive and more efficient. Uh, it transfers the shock to the hydraulic liquid, and after that, this shock transfers to the gas. And if you have a remained shock, it transfers to the fuselage and absorb that. Hello and welcome to the last episode of the aircraft structure educational course. Today we want to have a review of what we learned at this course. This is Airbus A300 aircraft, a wide body civil jet. Here we start from its landing gear. The landing gear, we told you that consists on strut, tire, ring, brakes, and shock absorber system. This shock absorber system is oleo. Oleo was a hydraulic gas shock absorber. Its main gear is twin tandem, called boogie. Twin tandem. 2 twin tandems are its main gear. What about its engines? Its engines are turbofan. Why? The most of subsonic civil jet aircraft are using this engine type because it has a great performance in subsonic systems. What about fuselage? Fuselage is semi-monocle as its shape and as the aircraft type. And the empennage. The empennage is the standard tail. And it's vertical and horizontal stabilizer, rudder, and elevator. And trim tabs are so small, which we can't see them here. And the wing. The wing is including its main structure, flaps, slat, spoiler, and the winglet, which decreases uh, the induced drag. And here we have a quick review. An aircraft is including five components: fuselage, wing, empennage, power plant, and landing gear. But how we control them? Here in cockpit, we can control the elevator and aileron by the yoke, the rudder by the pedals, the engine power by the throttles, flaps handle, spoiler handle, and landing gear handle. This landing gear handle is actually not hydraulic, it's electric, but it's designed as safety management like this. The throttle is increasing and decreasing engine power. Listen to its sound and watch the RPM gates. Okay, what about flap? The flap is controlled by this handle. Uh, Here we visit that from here. We can control the flap with this handle. It works with hydraulic system. The hydraulic pressure helps that to extend and retract. Watch this. Flaps extension and retraction. Why we extend and retract flap? We told you that the flap helps aircraft to produce more lift in the less speed by increasing uh, airfoil surface, increasing angle of attack, increasing camber line, and some other things like that. And uh, this aircraft has Kruger flap. We mean both of outbound and inbound flap are used in this aircraft. And the aileron. Airbus A300 is an special aircraft. which has no outbound aileron. It has just inbound aileron. But in the most aircrafts, the aileron just located on the aircraft out in the outbound of aircraft wing. Uh, its flap and the spoiler. We can control spoiler by this handle. And what about aileron and elevator and rudder? First of all, aileron. When I turn the yoke to the left aileron is moving upward, and the right aileron is moving downward. What happens? We told you that when we want to turn left, the left aileron moves upward. It means the negative angle of attack. And the right aileron moves downward, and it means positive angle of attack. So we have more lift on the right wing and less lift on the left wing. And this lift helps the aircraft to turn left. And opposite of that, when I want to turn right, you can see that the yoke moves to the right. The right aileron moves upward, and the left aileron moves downward. So what happens? We have more lift on the left wing and less lift on the right wing. And this lift helps the aircraft to turn right. Okay, here we go to the tail. If I push the yoke forward, I can descend. So the elevators are moving downward. And opposite of that, if I want to climb, I pull the yoke to myself and the elevators are moving upward. And I can climb. And the rudder. Look at these two pedals. If I want to turn right, I push the right pedal. The rudder moves to the right and I can turn right. And opposite of that, if I want to turn left, I push the left pedal and the rudder moves to the left and I can have a left yaw. Okay, here we have flight to see them during flight. First of all, I push throttles forward. Listen the aircraft engine sound. But before that, I should use flaps too because I want more lift in less speed. So I extend flaps, but not so much because the increasing lift means increasing drag, and we don't want drag more than usual. Okay, here we go. look at the 𝐾 and to the elevator. You can see that I pull the 𝐾 to myself and the elevators are moving upward and the aircraft starts climbing. Then, as we don't want drag, we should retract the landing gear. So these landing gears are retractable and they are retracted by this handle. Okay, here we have a left turn. It means that I should turn the 𝐾 to the left. Okay, what happens? I turn the 𝐾 to the left. See what's happening. The left aileron moved upward and the right aileron moved downward. It means what? Imagine that the aileron is an airfoil. When I decrease its angle of attack, so it produces negative lift. And when I increase its angle of attack, it means that it produces more lift. So we have more lift on the right wing and less lift on the left wing. It means that this lift helps the right wing to produce more lift and turn left. And I should say something too. In some steep turns, the spoilers can help the ailerons too. And after some little time, we should retract flap 2 because after a special speed called VMD wins the velocity of minimum drag, our induced drag, which depends on the lift, increases. Excuse me. Yeah, increases. So we should retract the flap. Okay, now we want to decrease our speed and our altitude and prepare for landing. what we should do? Uh, Here we continue our left turn. And it's another side too. You can see that the right aileron is moved downward and the left aileron is moved upward. When we want to start landing, we should extend our landing gear. You can see the strut, the axis, the shock absorber, the tire, ring, and brakes here. And this is called bogie. At landing time, we should use flaps too because we want to decrease our speed and we want to fly controllable. And here now we turned right and you can see what happened. The left aileron is downward and the right aileron is upward. You can see that I use rudder pedals too, and the rudder is a little turned to the left, as here. The left pedal is pushed and the right pedal is pulled. Okay, as we want more lift, we should extend our flap tube. And you can see the landing shocks now here. What are aircraft braking systems? Brake here, spoilers here, and thrust reverse, which changes the direction of the engine exhaust and helps decreasing aircraft speed. And as we told you, we can extend the spoiler here. You can see that spoilers are extended, thrust reverse is active, and we are using brakes too. Actually, it was the end of our educational course, and I wish that it helped you to know and learn many things about aircrafts and power-driven airplanes.